All right, so for this section, like I said, direct and inverse variations, there's two types of equations. Okay, I'm going to write them both down so you can see them. The very first one, we're going to call it direct variation. Okay, and the equation for it is this. Y over x is equal to k. Okay, this is the equation for direct variation. K is called the constant of proportionality. Or some people just call it the constant. Okay, and x and y are just points. Okay, so if you ever want to check to see if something is a direct variation, if something falls into this equation, this format, the way you do it is you get the y value and the x value that are related and you divide them. And let's say the answer is 5. Then get the next point and divide those. And if the answer is 5, okay, looking good. Get the next one, divide those. If the answer is 5 again, then that means that those points are related to a direct variation. Okay, so I'm going to show you examples on that. But I'm going to put a real quick hint right here. To check if points are based on a direct variation, divide y by x. In other words, y divided by x, okay? And the points should give the same answer. Right now I'm going to give you an example on this, okay? But if you want to check to see if a point or multiple points are based on a direct variation... Whoa. So let me give you guys an example of what this is going to look like, okay? So here's a quick example as to how you can tell if something is a direct variation. So is this a direct variation? So normally they're going to give you like some x, y values on a table. So we'll do maybe 4 points. So all right, so if you want to check if these points are related to a direct variation, what you want to do is you want to check y divided by x. Okay? If the answer for all your y divided by x's are consistently the same number, okay, then you are going to say, yes, this is direct variation. By the way, y over x is equal to k, right? So we're basically trying to solve for k. So let's check all the points. So the first point, 20 divided by 10, that's equal to 2, right? So that's k. That's my k value. All right, the next one, 18 divided by 9, that's equal to 2, which is also k. Now, just because you find 2 of them doesn't mean, oh, great, it works. Maybe one of these points doesn't work, so let's just keep checking. 16 divided by 8 is 2. And 14 divided by 7 is also 2. Notice all of them had a 2. So that means this is a direct variation set of points, okay? They do relate to a direct variation. Okay, so is this direct variation? Yes. Okay, I'm going to put, yes, this is a direct variation. So it's pretty easy to figure out if something is a direct variation based on points, because all you have to do is get the points and divide y by x. Okay, that's the important thing. Y divided by x, not x divided by y. Okay. All right. So in the very beginning, we started off with what is direct variation. Now let's define what is inverse variation. So inverse variation looks like this. xy equals to k. Okay, so it's going to look something like that. So like xy equals to k. Now, if you want to, again, k is a constant. Let me just write this down really quick. K is the constant. And if you want to solve, or if you want to try to figure out if something is an inverse variation, then we're going to kind of do what we did before. Like over here in red, we said to check if points are based on the direct variation, divide y by x, and the point should give the same answer. But we're going to have the same little hint right here. If you want to check if points are part of an inverse variation, then multiply y times x. In other words, I guess you could say x times y. Let me leave it like that because most people like to put it in alphabetical order. So you're going to do xy, and you should get the same answer. All right, so example number 2. Does this represent an inverse variation? Again, I'm just going to make a table. Go about 4 points again. Made that too long. Okay, so does this table represent an inverse variation? So what I got to check is xy equal to k. Okay, if I multiply x times y, that equals to whatever my constant is. Is that constant consistently the same? Right? So let me just check all the points. 1 times 12. Well, that's 12. So that's my k value. 2 times 6. That's also 12. 3 times 4. Also 12. 4 times 3. Also 12. So notice all my multiplications came out to the exact same thing. that means this is an inverse variation. Now, if you're wondering, well, then how do I tell if it's not? One of these multiplications would not be the same. Maybe I would have gotten 12, 12, 8, 12. Then you're going to say, wait a minute, why is there an 8 there? That doesn't, they all got to match. They all have to match. So if one of them doesn't match, then it's a no. It is not this type of variation, inverse, direct, whatever it happens to be. They have to match in order for them to fit. Okay? So I'm just going to say, yes, this is an inverse variation. So hopefully so far you're not thinking like this stuff is incredibly difficult. I mean, it's just based on definitions, okay? You got to make sure you know the definition. So direct variation is y divided by x equals k. Notice the k value is always by itself. You notice that, right? X, y equals k. Y over x equals k. So the k always has to be left alone. The number always has to be left alone. Now, why do I make this comment to you? Because of the following example. Example number 3. What kind of variation is this? Okay, so part A, let's do y equals to 5 over x. Part B, let's do y equals 2x. All right, so we're going to do those two. Remember, the whole thing here is to isolate the constant, okay? Isolate the constant. In other words, get the problem where on the right side it's just the number, and on the left side it's all your variables, okay? And then see which one it fits. So, for part A, I want just the number 5 by itself. So what do I have to move? The x. So I'm going to get this x and I'm going to multiply it over there. So that's xy equals 5. What kind of variation is the one that does x times y equals to a number? Inverse. So this is inverse. All right, well, look at part B. I want that 2 by itself. So what do I need to do? Divide by x, right? So I'm going to end up with y divided by x equals 2. What kind of variation is that? That's direct. So I mean, this isn't that hard, right? You just gotta make it fit the mold. Get the number and put it by itself, and then do the work. Okay? Now, everything, I mean, I don't know about you guys, but so far everything seems to be pretty easy. Okay? But there are other types of problems that they're going to give you. Okay? Now, I'm going to do one more random example, and then I'm going to do only one homework problem. None of these have actually been homework problems, but they all relate to them almost perfectly. Okay? But let me give you a problem here. Example number 4. This one is not going to be a homework problem again, but it is going to be related to the homework problems that you do. Okay, so given y varies inversely with x. Now, what they're basically saying here is we're going to be using inverse variation. Okay? That's what that first sentence says. Given that y varies inversely with x. So we're going to do inverse variation. Okay? Then they say, if x equals to 7 when y equals 2, what is y when x equals to 10. So this all sounds kind of weird, but they did give us the formula we have to use. They said it varies inversely. So this is the way I have always done it since I was in high school. Seems to be the easiest way to do these problems. Maybe there's better ways, but this is the way I always do it, okay? Since they said inversely, then I'm going to say, okay, inverse variation is xy equals k. Xy equals k. I'm going to do it 2 times. The first equation that I have there is based on the first part of this problem right here. Okay, see this right here that I'm kind of coloring in? That's the first part of the problem. Okay? The second equation is going to be for this part of the problem. All right? So, what did they say on the yellow one? They say if x is 7 when y equals 2. So let me plug it in. X is 7, y is 2. So what's my k value? 14. Okay, great. Now, get that information and plug it into the other equation. Xy equals 14. And now use the blue colored portion. It says, what is y when x is 10? So 10y equals 14. All I have to do is divide both sides by 10. And I get y is equal to 7 over 5. And there, I'm done. And it's the same thing if they would have said y varies directly as x. The only difference is instead of xy equals k and xy equals k 2 times, I would have used y over x equals k, y over x equals k. But I would have done the problem the same exact way. The first equation I find k, the second equation I find whatever variable they want. Okay? Remember, cut the problem into 2 pieces. Okay? The first part where they give you the x and the y value, the yellow one that I have, they gave us both x and y. You notice that? And then the second part, the blue one, they don't give me either x or y, but they will give me the other one. So now I got to solve for one of those, okay? So you're going to do it in 2 parts. Now, I told you I wanted to give you guys a homework problem, okay? So I'm not going to write it all out because it is a big old story, but we will write down the important stuff, okay? So listen to this problem. All right, so here we go. Or maybe, hold on, give me a second. All right, so I'm just going to write it out for you guys. So here we go. I'll give you a couple minutes to make sure you write it down as well. So the height of a wave in California varies directly so notice they say varies directly. This is direct variation, okay? Oh, sorry. Thank you. So the height of a wave in California varies directly, so direct variation, with the seconds that pass by. So with the seconds that pass by. Okay? At 4 seconds, the wave is 6 feet high. How many seconds will give you a wave that is 10 feet high? Now, don't get scared by the fact that it's a word problem, okay? Don't get scared. You're just looking for information. The first piece of information is what kind of variation. What kind is it? Direct, okay? That's the most important part because that tells you what kind of equations you're going to be using, okay? Then you look at the next sentence and notice they tell you a time and a height. They literally give you both time and height, okay? And then when you look at the rest of the sentence, they say, oh, here's the height, but we don't know the time, right? It's kind of like the other problem where I gave you the x and the y at first, and then I only gave you like x and you had to figure out y. It's the same thing. They just padded it with a bunch of extra stuff. Okay, so for a problem like this, we need to figure out what do we want to call x, what do we want to call y. So it says the height of a wave in California varies directly with the seconds that pass by. It says at 4 seconds. So since they mentioned seconds, first let's call that x. I'm going to put let x equal to the seconds, and y will be the height. And remember, you can switch it. You can let x be height and y be seconds. It doesn't matter. Just make sure you keep that consistent, okay? Make a choice and write it down. Okay. Since they say we vary directly, I'm going to write this equation 2 times. Okay? 2 times. Every time you write it down twice because there's 2 pieces, right? The first piece says at 4 seconds, the wave is 6 feet high. At 4 seconds, the wave is 6 feet high. So 4 is x and 6 is y. So 6 over 4 equals k. So k is 3/2. Are you guys okay with this so far? Anybody have any questions on that one? All right, so now the next part is I have one right here. Let's look at the other part right here. It says how many seconds will give you a wave that is 10 feet high. Okay, how many seconds will give you a wave that is 10 feet high? So my y value, the height, is 10. My x value is unknown. So let me rewrite this part right here. Y over x equals 3 over 2, right? Because we know k is 3/2. And we know that x is 10. I'm sorry, y is 10. Okay, so all I have to do is solve for x. Okay, so has a teacher ever taught you guys a shortcut? I'm about to show you right now. I'm not sure if you've ever seen this, but whenever you have a fraction equal to a fraction and you have a variable on the bottom, did you guys know you can just flip everything over and it's identical? In other words, I'm going to put a little mark right here. X over 10 is 2 over 3. Did you guys know that? If not, very useful trick. You can just flip them. Okay, just flip them over. So in order to solve for x, what do I have to do? Well, no, the x is on top of the 10. Notice division by 10, so multiply 10, right? Yeah. Divide by 2. I mean, I can move that over. It'll become a 20 on the bottom, but I'm still going to have to move that to the right side. So I'm going to multiply by 10. So x would be 20 over 3. And that would be the time. So 20 over 3 seconds, what is that? 6 2/3? No. Yeah, 6 2/3. So 6 2/3 seconds. That's how long it's going to take. Okay? Notice I know it was a big old word problem. I'm just going to kind of zoom out a bit. I know it was a big old word problem, but we treated it just like the other problems where we said the first sentence, the one I did in yellow, gives me X and Y so I can figure out K. And the second sentence, I already know K. They'll either give me an X or a Y, and I just got to figure out for the missing piece. Okay? So it doesn't matter what kind of sentences they use. It's all the same work.
Where did you get the 6?
Where did I get the... Oh, the 6 2/3?
Yeah.
That's 20 over 3.
Oh.
Yeah, I just wrote it as a mixed number. That's all. Yeah, so at least I think I'm right? 23 goes into 26 times. That's 18 with remainder 2, so 2/3. Yeah, 6 2/3. So, any questions on this one or any other questions? All right, so we're done.